Yeah, so just to repeat, welcome to the VEP discussion meeting, and Asif is first on the agenda, and yeah, take it away.
Yep. Does everybody hear the audio here? Right, let's do.
No, I can hear you, but not the audio.
Okay, well, I think I'll just present it manually then. Sorry, one sec. Let me just. Nope, not this. Okay, so I have so VEP 248 presents a stall detection algorithm. I just want to go over how this stall detection algorithm works. Maybe get some feedback. Also, this VEP also doesn't have a shepherd yet. I know Itamar asked me about this VEP, so I don't know if Itamar would be interested in shepherding this VEP. But here's essentially how this algorithm works. So this is the standard case for how I'm imagining a stall detection algorithm works. So what's cool about this algorithm is that it doesn't just detect stall, but it also tries to trigger the switchover at a local minima, which decreases the downtime. So here's how it works. So we define something called a progress window. So this rectangle here represents a progress window. And what we do is at the end of each iteration, we compare the remaining bytes on the current iteration to the lowest known remaining bytes in whatever is outside this progress window. So next one, this is still the lowest remaining bytes outside the progress window. Next. And now since this is the lowest outside the progress window, we compare whether our current iteration is higher or lower. Since it is lower, we still detect that we are not stalled. And now it's at this point that we detect that we are finally stalled, because this point compared to this point is actually slightly higher. So we detect that we are stalled. And the point of doing this is because temporarily the remaining bytes can temporarily go up, and we don't want to falsely trigger the stall detection algorithm if we aren't truly stalled. So if within progress timeout you don't actually make you don't make progress for this long of a time, then that is when we detect that you're stalled. So once we are stalled, what this algorithm does is it looks at, okay, all the points so far, what is the lowest point we have seen? And then it uses the lowest point we have seen as a local minima, that, okay, since this is the lowest point we have seen, we want to try to get at least this good, instead of like triggering the switch over randomly. So in this particular case, since these 2 points are close enough, the algorithm would switch over right now. And this was the example I wanted to show. So this is from a MariaDB workload that, as you see, temporarily the remaining bytes can go up, but if the progress timeout window is large enough, because it like temporarily goes up here, the nature of this algorithm prevents it from falsely triggering stall detection when you aren't truly stalled. So this particular case actually finishes without the stall detection triggering at all. And then also network failures were considered in design of this algorithm. So as you see over here, bandwidth goes down. That temporarily causes the remaining bytes to go up. This is actually probably the only, I'd say, weakness of this algorithm, is that since the stall is actually triggered by bandwidth going down, which makes the algorithm think that we are stalled, even though once the bandwidth returns to normal, we continue making progress. But because stall has been detected, it will actually converge as soon as it gets at least as good as the previously best known value. So trigger the switch over here. Even though, as you see, had we like continued longer, it actually converges naturally. So this is one limitation, but I don't really see a way around it, at least not without adding significantly more complexity. And in the interest of time, I'm not going to go over this example, but the algorithm also has a relaxation portion to it, because sometimes due to phase shifts in the underlying program, you can see like over here, dirty rates are stable, but then dirty rates temporarily, like dirty rates spike. There's an underlying phase shift, and that causes remaining bytes to like stay elevated for an extended period of time. So in cases like this, there's a relaxation period where the local minima of remaining bytes is the requirement is relaxed. So this is the crux of the stall detection algorithm. There's more details in the VEP, and still looking for a someone to shepherd this VEP, and that's all I got for now.
Yeah, I'll be happy to work with you on this. We could also, if you'd like, we can create some kind of a ad hoc meeting and get the right people in the room to kind of go deep into this.
Yep. I also, by the way, I also present so there are some hyperparameters here, like progress window size. I also present justifications in the web for what I think would be a good default. And there are lots of other justifications for why things are done the way they are. And yeah, we could definitely schedule another dedicated meeting. If anyone has any comments, we can talk about it. Otherwise, we could move on to whoever wants to go next.
One question: Is it? Do you have it already in the web? It's like really cool plots. I would like to take a look at this.
Yes. So the web actually has link to the slides for the data and also a YouTube video where I explain this in a little bit more detail. I go through each example because I was afraid maybe the web reading it, like reading the words might be too confusing. So I thought it'd be easier to have some visualization as well to make the point clear and explain with data why things are the way they are.
Amazing. Thank you.
Yeah, thank you, Asif. I will also have a deep review, and yeah, thank you for all of this effort to make it easily readable and understandable. That's appreciated. Thank you.
I have only one small question because I didn't read the web at all. So the convergence of the migration, I mean, it's one part is that manages it is KubeVirt itself, right? But you also have the hypervisor behind it. So what will be the difference between one managing it and the other? Like it
So,
also does convergence thing there, right?
Right. So when QEMU or whatever hypervisor have their own downtimes, you can still naturally converge. The only point of this stall detection is act as a backup mechanism when the downtime that you configure, the target downtime, it cannot be met, and your migration has stalled and is fluctuating between a certain number of remaining bytes. So that's when this kicks in. That's when this mechanism kicks in to make sure that the migration actually converges without waiting all the way for the timeout, which can take several dozen minutes. And of course, the point of that is because many end users of KubeVirt might be paying per gigabyte of bandwidth used, and migration can take a lot of bandwidth.
Okay, so my question was specifically, just to clear, it was specifically why the implementation cannot be done in the hypervisor. That's it. Like that. I mean, that was the question more or less.
Because the hypervisor itself, I think, it doesn't take any action. I mean, we are the ones who have to take the action. Some kind of a high-level application. What do we do? Do we switch to post copy? Do we pause? Do we cancel? Something that the hypervisor itself doesn't take a decision on.
Right. So this decides when we switch to post copy. Just same way like we decide right now when we switch to post copy or stop and copy.
Yeah, thanks.
Mikkel has a question too.
I was just wondering if it makes sense to mention the last item in the whole list, which is sort of alternative, very naive, simple implementation of only part of what you're trying to tackle, which has far less data behind it, and it's not so elaborated, but it could improve the migrations as well without too many code changes. It's trying to tackle a different problem originally, but I think it is related. in a way.
Yeah, me and Mikhail think about this offline, but essentially his VEP is a little bit more it's simpler. It can be implemented in only a few lines, so it's easier to review. There's a little bit less risk. So we also discussed whether if you want to get this feature in quickly, maybe it might also be worth considering what he proposed. But I think this is probably something we can talk about offline.
Yeah.
Right.
Any final thoughts on this before we move on?
So who is going to set up the meeting for this? Because there was not any intention to go into so much details in this meeting, rather than to poke people into the right direction. Asif, can you ask Andrew Burden to set up a meeting for us or for folks interested in live migration?
Will do.
For example, for the next week. Perfect. Thank you very much. And let's move on for Itamar, because I see the agenda is very packed today, so I want to give time to everybody.
Yeah, so I'll try to be quick. So basically, I have a PR to enable beta features on by default. So there was a VEP behind it that was already merged. There was like a pretty long discussion over there, but it, like not everybody participated. But so I just wanted basically to make sure we're on the same page and there is not like a substantial pushback to this approach. So just to summarize, what we came with two conclusions, basically two decisions. One of them is to turn every beta feature on by default without any further configuration, which means that like being beta means being on by default. Like there are no exceptions to it. And the other decision is that with every KubeVirt release, we will also post, like as part of the release artifacts, a JSON with a very simple format that basically lists all of the non-GA feature gates, so that basically vendors would be able to easily turn them off in production. This basically means that every downstream vendor of KubeVirt will have the responsibility to turn beta features off by default if they wish to. Yep, and that's basically it. Lubo, what do you think?
So I don't have objection for the enhancement as it, but I have two asks. One ask is to go through all the existing beta features right now and to justify that they are safe to actually enable them by default, because I think that's something we were not doing previously. And the second point would be, let's open a PR against the enhancement template to have a mention here that, hey, if you are graduating this to beta, is this safe to actually being enabled by default? Because that's the norm. So some kind of check mark. Let's put it this way.
Yeah, I have no problem updating the web template. With respect to the beta, to the current beta features, so I mean, even if we find that something is not ready, we will face a problem because like there is no configuration to disable it, basically. In the PR that I made, basically all the CI passes there, and there are not like that much changes to adapt it. So I am turning off image volume for like 2 tests that Barak told me offline that he wanted to delete anyways. So you can see that the actual changes that I made to make it pass, and I don't think that's like a huge changes. So I think that we're at a pretty good state. Yeah, that's my thoughts basically.
Yes, that's fine. But for example, for the image volume, if somebody is using and they are able to do so, older release of Kubernetes, and they disable the beta features there, then this would not work, right? So for me, this is not safe as a feature to be enabled by default. I guess it's if we don't have it, and I apologize, I need to review your PR, but if we don't have it, maybe we can have a like default that can be overridden. So for that feature, we could always set false for now.
So yeah, to me, it's mostly a matter of responsibility. So I mean, I would recommend, maybe we should do it like in some kind of a document somewhere, but I think we should recommend explicitly to every downstream vendor, disable beta features like by default in production. You can enable something if you want to, but it's your responsibility to do so. We provided JSON, so it should be very, very easy to do so in production, but it's your responsibility, right? So if you install KubeVirt on like Kubernetes 133, then that's fine, but it's going to break, right? If you don't disable beta feature gates, and it's, again, I see it as a like plausible responsibility to give downstream vendors to do that. And by the way, I think that in Kubernetes it's basically the same thing, right? So not all beta features are enabled by default, but most of them are in Kubernetes. And I guess that like in most downstream vendors, they go and disable, or at least they make an assessment like on which features they want in their production environment or not. I just don't think it should be like our responsibility from an upstream perspective to take care that every downstream vendor like disables the right features on the right Kubernetes version. I think that it makes sense to delegate the responsibility to the downstream vendors. That's basically my stand.
Yeah, I agree with you that each vendor needs to do their own. But here it's more of more from our point of view. Are we okay with going into inconsistent state where we say following beta features will be vetted against if it's saying to be on by default, but these old ones we don't really go through them and say to ourselves if we think it's safe or not. So just to not get into inconsistent state where the old one we don't care and the new one, yeah, they will be safe from our point of view to have them by on.
Yep, got you. Just a final word on this, that in the PR, what I did for image volumes, for example, is that I disable it on RCI if Kubernetes is under 135. And in our downstream, we can disable it altogether as long as it's not GA. But yeah, I think that yeah, we get the idea, and yeah. So if there are other thoughts, let me know, and if not, I encourage you to review the PR. Thanks a lot, and if there aren't any other thoughts, Anish, you're the next one.
Hello. Yeah, so let me quickly share my screen. So basically, I just want an overview or suggestion from the community. So the web is regarding the VM network bandwidth limiting. So basically, the motivation of this web is to like just solve the noisy neighbor problem that currently exists. So basically what happens is in a multi-tenant or high density environment, there can be some VMs that might take the whole network bandwidth of the host. So basically what the proposed solution is like this. So we introduce a new API that is bandwidth, which will take two parameters, inbound and outbound, having the parameters average, peak, and rush. This will be translated by the translated to the libvirt domain XML. So for the provided API example, this is what the translations provide. So I have got this web reviewed from Ananya and Asif. So what are the validation that we have been through till now is we basically avoid the outbound peak rejection because the Linux ingress filters drop drop if the packets are above certain period instead of queuing it. The second is there are some tab devices such as SRIOB and MapTab that doesn't support this API because they overrule this API. The third is normal integer overflow, that the values provided are not negative or above the int max value. And the fourth is the logical constraint, basically a very small one, that the peak should always be greater than or equal to the average one. So yeah, this is what the web is about. So any suggestions?
I just wanted to check, is your proposal including and explaining why the alternative of using a CNI to do this bandwidth limitation not enough?
I don't think so. It is there. No, I have to add it. Yeah.
We're talking about the CNI bandwidth meta CNI plugin, right? That's okay.
Yes.
Okay. Because
Yeah. Also, Ananya has offered to be a shepherd, so it is not yet updated in the project org list, projects web org. So like if this, yeah. Yes, I see.
So I know usually for webs, a lot of the discussion often involves around the API changes, because the API changes are something once we make, we are often like sort of stuck with it. So I wonder if instead of just having like a direct bandwidth pass through, maybe I think this has been like talked about a few times in different contexts, but like defining a policy of like what you want. Maybe you want to for each VM on a node, you want to give them all the same bandwidth limit, like distributed equally, or maybe have some overhead bandwidth. Basically, what I'm saying is automatically configuring bandwidth limits based on some policies rather than manually having to configure bandwidth limits per VM. Just a thought.
So for this, I thought like we can use policy validation tools like Kyverno to handle this. So basically, like if any thoughts on that, or
No, this is separate from the policy validation. This is more so
oh,
like instead of configuring the bandwidth limit per VM, maybe it might be better to think about the use cases and like think about this at a more higher level, that maybe instead of a per VM bandwidth limit, you set a policy on a cluster-wide policy, or maybe a node-specific policy, that all VMs on this node will have a certain bandwidth limitation or something along those lines.
let me rephrase it. I agree, and I will rephrase it a bit differently. How you will manage VMs, like you have a cluster with 1,000 VMs. How do you manage them now? With this kind of, what is I mean, the problem here is what is the scenario, and how do you, in a cluster with a lot of VMs, what is your needs exactly? Do you have each one of the VMs will have a specific configuration? Does it have policies? Stuff like that. That's the I want it to translate it also to this.
yeah, I understood the problem. So yeah, so we can. I will look into it. So I will, based on that, I will update it on the web. So any further questions or suggestions? So yeah, so okay. Thank you, folks.
Thank you very much. Just a tiny note that I forgot to say in the beginning is that there are two important mails for VEP owners. You can find them in the chat and in the beginning of today's agenda. But yeah, let's move on. Joao, you're next.
Hello.
Take it away.
Yeah, it's still disabled, the share. I think Nish needs to stop share. Thank you. Okay, so today I just wanted to raise awareness for these two VEPs. The first one is about GPU metrics, that currently we are not exporting anything related to GPU to Prometheus. And I started looking into this, and tools like NVIDIA Operator provide the DCGM exporter to fetch GPU information and expose them to Prometheus. But the operator disables this as it does not work on GPU pass-through and on vGPU. So what they recommend is installing this or some agent monitoring this inside the guests. Actually, my initial approach was trying to discuss with the Kemu guest agent team to see if we could export this data through the guest agent, but they were not. They did not want to add very specific vendor information on the guest agent. So I decided to follow this approach and having an exporter and an agent specifically for this GPU information on the guests. And similar to what we do right now with other guest agent information and even with downward metrics, using Vertio serial to communicate this information from the guest to Virt Launcher and create a new Virt Launcher gRPC endpoint so that we can get this information to Virt Handler, and from there, as we do for the other VMI metrics, to Prometheus. So this is more or less the idea behind this web. So I just want you to try to take a look and review the web and give me your opinions on it. Yeah, the other one I discussed here in the past, it's about the monitoring separation architecture, having the specific observability operator for all the observability related metrics and the Prometheus rules management. It's been a bit stalled lately, so again, just wanted to raise some awareness, asking you to please take a look and see if you have any opinion, something I need to change. Yeah, and that's it for me. I don't know if you have any questions.
Yeah, from my side, I just wanted to say that the other web that you were mentioning, I listed myself as a web reviewer for it to shepherd it, and yeah, it's definitely on my to-do list. The war and holidays didn't help me to do it in time, but yeah, I will get to it as soon as possible.
Yeah, thank you. I see that Felix also.
Yeah, I just want to comment on this web.
Yeah.
I have to be a bit hesitant. Are we sure we want to like explode the word handler functionalities to put even more stuff in there? It's, to me, this feels like it could be something that's purely based on stuff running in the guest. The guest could have an exporter. So
no, yeah, that's the main idea. And right now we are passing it through the Virt Handler, but this is really related to the other web. So the other web, the idea is to remove all of those computations that are currently happening on the Virt Handler and moving it to the new observability operator, right? So, but while that is not merged, this is the current approach, right? It's what we do with the Kemu guest agent, and as I said, the downward metrics. So that's why the wording here is like the previous way of doing things. That's what we currently do. And again, yeah, the idea here is that everything is collected on the guest agent and it's exported, and Virtendler really is just like the pass through, because Prometheus queries the metrics endpoint on Virtendler side. So there's really not many operations right now on Virtendler, just really the exposition. But yeah, on the other web, the idea would be to move that to the new component.
I see. Okay. And how would it work? Like, would you attach multiple Word.io serial devices to machines if we have a guest agent already, or how does that work with one single serial device?
Yeah. No, I already did like a POC, and the idea is that if we attach any GPU device to the VME, we'll create the new Virtio serial, and the agent running on the guest will respond to the queries over this socket and expose the information there.
Okay.
Yeah, as I said, yeah, I follow more or less the same approach as we do for the other data that we collect from the Camel gas station and from the downward metrics. Yeah, I saw in the chat about VSOC. I tried VSOC initially, but I was not sure that it was available on Windows guests. So read somewhere about it. So because I started working with VSOC, and actually I was able to get it working for Linux guests. But yeah, then I saw that about the Windows guests, and I tried to use in the Virtio serial. I see more raised hands.
Yeah, hey, I think I'm next. So, yeah, one of my questions was about VSOC that got answered. The other question is, does this effort also include getting things like XID errors or error states um, from the guest?
Right now, I've only looked at this information that is collected by the NVML bindings, but I can totally check if we can fetch additional information like the error messages and not only these counts that I listed here.
Yeah. Okay. And can you talk a little bit about what this Word IO ports, like /dev/Word IO ports, are in the in the diagram? Sorry.
My bad. Sorry. Going back. Okay, this one.
Yes, the /dev/Word IO port. I assume that is the Word IO port where the communication is happening.
Yeah. It's I create the Unix socket and connect through it on the guest side with the agent.
Right, and that socket is a bidirectional unit. So when that socket on the host side is presented as a device on the guest side, it will still continue to behave as a bidirectional socket.
Yes, because I do it on, for example, each time we get a query from Prometheus or the cache timing hits, we query the agent running on the guest, and only then the agent collects and connects to the NVML bindings to gather the data, so we don't overload the agent and only collect this information when we needed it. So yeah, it's bidirectional.
Got it. So in this model, it will only be pull only. Whenever we want a Word launcher to query, it will query it on this port. There will never be a push where something happened on the guest VM and information is pushed into Word launcher. Is that correct understanding?
Yeah. Right now, yeah, it's only on a poll basis.
Correct. Okay. Yeah, I wanted to express similar opinions as shared by Felix earlier. The fact here that we are decoupling or we are coupling the implementation here with a gRPC metric, gRPC serve like gRPC, uh, method in Word Launcher is something that I'm a little bit concerned about. Like so this work looks like it will evolve over time, and once we introduce that RPC method, it's hard to evolve that API. So I would be curious to hear if there are mechanisms to avoid having an RPC communication, especially between launcher and handler.
Yeah, as I said before, that's one of the issues that we also been facing, namely with the Camel guest agent, because they all are also involving the data they export, and we face that issue many times that we want to collect different data that they are now exporting. One recent example was the CPU load information that was recently added, and we faced those exact same issues, and that's why I created the other VEP, is to try to make it more flexible how we are exporting this information on the Virt launcher side. So yeah, the problem you are mentioning, I definitely agree with it. I faced it, but I try to follow like the current approach and what it's currently done here, because I already have the other one that would try to fix it, right? I just didn't reflect it here because it's not accepted or merged yet.
Yeah, that makes sense. And I know we need to move on to the next topic, but if this is a known problem, maybe we should not be building on top of it, right? Can we defer this work until this problem is solved? I think that is one of the open questions we can discuss offline.
Yeah. I guess that just like a small also implementation detail. That's why I didn't want to stop all of these because of the RPC call, right? Because I think a lot of decisions, as you guys asked about the Virtual serial and the VSOC, will probably mean a lot more changes, and we can start discussing that and deciding that. Then how we export the data to the outside, it's probably a bit easier. But I definitely agree with your concerns.
Okay, thank you.
Yeah, thank you. Yeah, I guess that's it. Thank you for your time.
Thanks a lot, Joao.
Yeah.
All right, let's move to the next one. Arnon, I think it's you.
Yep, it is. So I just shared the VEP. We started discussing it a few months ago, before the war and stuff here. It follows up a discussion we had with several backup vendors regarding file level restore, which was not which we didn't have any support for in the domain of KubeVirt so far, and for good reason, because we usually don't get into the guest. So after some discussion with both SIG storage folks and other friends here, we try to separate and keep the KubeVirt the KubeVirt area quite clean and sterile, and refer a guest helper, not actually an agent, but just an helper who is doing the guest OS specific file operations. Okay, which is totally different. For example, in Windows, NTFS, BitLocker encrypted the volume, and the Linux world, for example. We want to support both, but we don't want to care about it from the KubeVirt side. So maybe I'll share the VEP. It's quite short. Can you see my screen?
Yep.
Yes.
Okay. So I already got some feedbacks from mostly SIG storage folks, and I'd like to get some more from the non-storage folks, because I think the guest side helper smells a bit funny, because it does most of the dirty work here. It does the actual file copy, for example, from a backup PVC to the guest file system and so on. So I wanted to hear your opinion on it. What else? In addition to that, we in the beginning we suggested doing it via SSH over VSOC, so the communication would be only from the host to the guest. But then we got some feedback from folks like Michael, who said why complicate it and not simply do an SSH. Because most VMs have network, and it's not as safe as SSH over VSOC. So we started with it and just mentioned the SSH over VSOC on the bottom of the VEP. Now the guest helper is currently designed as simply a helper binary or a script, which has a trivial CLI API, just giving for example, the mount path and source path, and then it knows where to grab the restore files from. Okay, where the KubeVirt side is simply attaching a backup PVC or a volume snapshot based PVC to the VM. And from that point, the work is done by the guest helper. So I guess most of you can add their feedback here, because it's not a standard KubeVirt VEP, because it involves internals in the guest, although they are not part of the VEP itself.
Yeah, Arnon, just some initial, I know you just recently updated this, but I see that you're still like, the repo is KubeVirt, and this seems to me like something that can live totally outside of KubeVirt.
The code, all the stuff in the VEP itself is not involving the guest at all. Okay? The only part
I'm talking about like the code, where the code for this feature is going to live. I don't think it should be in KubeVirt. Like there should be some other repo. Like there are no changes to core KubeVirt for this, is my understanding. No changes should be required.
When we move to the SSH over network, I tend to agree that it's not a must-have. We can implement it as an independent operator or something.
Yeah. I think that's just looking at that. Like, can we think about this being, I think because that will give you, I think, a lot less scrutiny as well. So I think you're going to have a lot more freedom to do what you want to do in a repo outside of KubeVirt that is not, supported, installed with KubeVirt. So I think that would definitely, I think this is, definitely get you more favorable opinions if this is not at all linked to core KubeVirt, because you should be able to, from some other operator, hot plug the volume into the VM and do whatever you want to do. And yeah, it shouldn't require keeper code at all.
Okay. Do we have a reference project like this that is doing it externally to Q? I know
like Vert. You could look at like Vert template or something like that. Like this is code. Like there are a lot of some projects that use core KubeVirt, but are not built and deployed and tested with KubeVirt.
Yeah, for example, application aware quota and templates, Vert templates, and then a bunch of others. I can give you example. I have well, maybe not specifically. I have a few.
Okay. But since it deals with both hot plugging volumes and execution of code in the guest, I guess it's relevant to review it by our folks here, right? Because it's not external to Qubit. I mean, it can be implemented, of course, totally externally, but its usage is irrelevant to other projects. It's totally KubeVirt related.
Yeah, it's definitely like, yeah, you're using KubeVirt APIs and doing stuff in KubeVirt VMs, but yeah,
Okay.
It shouldn't be, it just doesn't have to be in the same repo as KubeVirt is the point.
Okay.
Yeah, we did have a VEP for like if it has to live in the KubeVirt org, then probably a VEP is a good way to go. But yeah, in general, I totally agree with Michael. If you can just use KubeVirt APIs to do what you need, it's the best.
Okay, but keeping it inside the KubeVirt org is natural, right? Only externally to KubeVirt.
Yeah, keeping it in the org is fine.
Okay.
And definitely I think to get something in the org, you should have a vet for it. But yeah, so I think just in the org, I think is fine. It's just not in the KubeVirt repo.
Okay. Got it. Anyway, any reviews would be really appreciated.
Right, thank you very much. And moving forward, Sheng, you're next.
Hey, okay, hey there. Let me just quickly share my screen.
Yeah, no, you can just stop the sharing.
Okay. Okay. Figuring out how to share the screen. Okay. Okay. Yeah. Take my screen.
Yep.
Okay. So hello everyone. So today, I would like to discuss on the MDS support in KubeVirt VMs again. So there was a previous VIP, but now I have revised the VIP to use the dedicated MDS CNI after the after receiving reviews from the communities. So as compared to the previous privileged sidecar approach. So as a high-level overview, let me just going to skip some of the details here. Here. So as a high-level overview, the VIPs has two parts, and one is network plumbing for rerouting the packets to the 169.254 MDS address to localhost. And the second part is allowing the developers to bring their own MDS server implementation via the binding sidecar. So let's just go over some of the high-level use cases for now. So as I mentioned before, the VEPs has two parts. So for the MTS CNI, it's mainly for responsible for handling the network plumbing. So when a user tries to issue a request to the 169.254 address within the VMs, the CNI will kind of configure the pod network namespace so that the traffic to the IP address will be steered into a listener that's listening on the local host. And in terms of like implementation, one example that we can do is to attach the 169.254 address to the loopback interface and use DNAT to redirect the TCP traffic to the interface. And as for injecting the sidecar, which actually hosts the HTTP server to listen to the 169.254 address, I am proposing to inject the sidecar using this binding sidecar, which we specify in the KubeVirt CR. So the sidecar is expected to listen to a port on the local host where the traffic will be redirected to. So let me just give you some kind of a quick CR overview of what this will look like. So in the KubeVirt CR, we can kind of specify the binding configuration. So here I am proposing to have a new metadata service binding with a dedicated network attachment definition for VMs with Multis networking. And this is where the sidecar image can be specified. And this is what the NAT will look like. And in the JSON file, we can pass in like different configurations and parameters if we need it. And this is what the virtual machine instance that's basically leveraging the CMI looks like. Yeah, so this is a brief high-level overview of this VIPs. So I just want to pause for a moment and see if there's any feedback from the community on this approach.
So I have one question because we also are short with time. Do you expect to have changes in KubeVirt over this? Because I'm seeing you are using the existing mechanism. So do
Yeah,
you
so
integration?
we will have to make change on the word controller to kind of to support the additional sidecar. I'm not sure.
No, you are using, based on what I'm seeing, you are using an existing binding network, and that's given already. So you are not. Why would you need? Anyway, we can discuss it on the, I guess, on the PR or offline. But based on what I'm seeing here, you're using an existing pluginable solution, so you are not supposed to require anything based on what I'm seeing.
Okay, so how about the additional MDSCNI? Would that be something that could be potentially be upstreamable?
It's there are already vendors that are creating their own CNIs and creating their own sidecars images. So yes, you could do it. You can do it on yourself and then try it out. And should it live inside KubeVirt.org? I don't know. It's you could suggest it basically. Yes.
Right. Yeah, so that's that was one aspect of the proposal. See if that's something that's potentially upstreamable to the Cooper community. But I guess we can discuss this offline a bit. Okay. Any other questions before? Okay, if there's no immediate questions, I will kind of leave the VEP on the calendar agenda. So like any review and any feedback will be appreciated.
Thank you, Shane. We have 2 minutes left. Michael, do you want to have a quick one?
I think he left the meeting earlier. He said in the chat.
Got you. So, Michal, maybe we can talk quickly about.
He also left the meeting.
Oh, sorry, I'm here. I was muted. Am I sharing something?
Yep, go ahead. We have
Okay.
1 minute, but
yeah, super quick. I think these are super easy ones. It should be pretty non-controversial. I just want to, so for this one, I want to add service account name to VEP right now to the BMI. Right now, to have the Vert Launcher Pod run as a service account, you have to create a service account volume. So the service account volume, it's kind of coupling two things. You're saying I want to run as a service account and I want to mount the token in the VM. And this is just decoupling that. And this came out of the container path VEP, where it was kind of awkward, where even if you didn't care about having the service account token, you had to kind of put it on your VMI spec. So what this allows for is kind of just a more simpler declaration here, because before you had to have the container path and the service account volume. Now you can set the service account here and just have the container path volume. Just decoupling those two things is what I'm proposing here. I think that's pretty straightforward. Secondly, and this one again should be pretty straightforward, raw IO for LUN disks. Basically just adding a field to the LUN disk type to support raw IO. The only reason this is even VEP really is because this raw IO requires this special capability, sys raw IO. So we gotta have to like change our security context constraints, and this again, very straightforward, just requiring raw IO for LUNs.
But how will this work? I mean, this would require like on OpenShift, for example, a non-standard SSC.
Correct. You can't run it in restricted.
Yeah, but isn't making it by default? Yeah, I don't know, Luba. What do you think about it?
It would only be for this if a VM has raw IO disk. Would we add this? This isn't something we're adding all the time.
Yeah, you promised something in non-controversial.
So it's not all the time. It's just for this disks, and it's turns out it's actually really important for certain use cases because you need this raw IO to update like some firmwares and whatnot.
But okay, why couldn't this be a plugin, for example? So Itamar is working on the Web 190. That could be. So, for example, all of these changes that are required for on the Vert Launcher pod could be added as a PS, as a mutating admission policy, and then changes for the domain would be handled in like a standard plugin, and then everything else here is basically sounds to me like a plugin.
I guess the big thing is Vert controller needs the allowed capability to create a pod with the raw IO capability. And I think this is just a nicer API. I mean, just to have it at the API level.
No, I mean, I don't know. I really don't know because this is our core assumption was that our VMs will run always with default SSC. And then whoever wants to create something else, anything else, would have to have another implementation outside of KubeVirt. So I don't know. For me, this is very controversial.
Okay, well, we'll talk about it. I mean, I think that this is going to be used very rarely. There's obviously a feature gate for it.
Let me sell you a plugin because with plugin.
No, look, the plugin is cool, but it doesn't address the fact that Vert Controller has to create the pod with the capability.
No, I think it could solve this problem, but yeah, let's take it offline.
All right, I'll take a look. But again, this is a pretty narrow cases in which this will be added.
Okay, I really have to drop, unfortunately, but yeah, we have to talk about this. Thank you.
All right.
Bye-bye.
Yeah, thanks a lot. We actually made it through the agenda, only 4 minutes after. So yeah, thanks everyone. See you next week.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.